Hey everyone. So we're in the statistics and probability class on Khan Academy. Today we are looking at, we're in unit one, so analyzing categorical data. And this is a question set that I gave three question sets to students that are kind of similar. One of them was really particularly tricky. So there was analyze two-way frequency tables, interpret two-way tables, and trends in categorical data. So it was the trends in categorical data that was tripping people up specifically. So I want to look today at this question set. I want to start with just an opening example real quick at what the types of questions that we're going to look at here and some of the mistakes that are most, or that I think are most common, something to look out for. So what I have here is some data from the Titanic. So this was a ship, I believe it was like 1912, it was just over 100 years ago, that sank on its first voyage. So as we can see from the data, the majority of people did unfortunately pass away. But what I want to point out is some of the most common mistakes that we can make here. So if I'm looking at the overall data here in the table, on the left I have survived and died, so I know whether the person lived or died. And all the way on the right I have my total. So what I'm seeing from here is that the majority of people actually died, 1,490 out of 2,000. I'm going to calibrate my mouse here too. I'll just keep going with it. 2,201. So 14,090 divided by 2,201, that's the percentage of people who died. And 711 divided by 2,201, 201. Sorry, I'm working with a different mouse and computer today. I'm hoping to get it fixed, but it doesn't seem like it's working very well. But that's all I have. So 2,201. So 711 over 2,201. So about 2/3 of people died, about 1/3 lives, it appears. And what I want to point out is the strange kind of thing that we might find here is if we look at the percentage of people who survived, it turns out the biggest represented group in here was the crew, which is surprising at 212. So if I turn these into row percentages, the biggest percent I'm going to get is 212 over 711. And that might be a number you look at and say, okay, if I survived, I had the highest chance that I was actually from the crew. If I pick a random survivor, it'll probably be a member of the crew. So they must have done pretty well. The problem is you can see here that the crew just had a larger representation. So there were just more members of the crew. So even though there were a lot of them that lived, there were actually a much higher percentage of them that died, 673 out of 885. So a better way to actually think about this is to look at the column percentages. So to look at each column individually and say what percent of people lived and died. So out of first class, for example, more than half of them survived, 203 out of 325. So they had somewhere around a 60% survival rate. It was much, much higher than 50%. In second class, the majority died. So the trend kind of flipped. So the majority died. Third class was the same, but a much higher percentage relative to second class. And then crew also had a very, very high percentage. So it seems like third and crew actually did the worst, even though by pure numbers, and if you look at row percentage, it would be a high percentage of people who survived are from third and crew, even though they actually had the lowest percent chance of survival. So these are some of the things we're going to look at in the question set today. So let me clear this to the question sets. So we don't want to be fooled by percentages that are telling us something that is not true. All right, so this question says, at a popular rock climbing site in Yosemite National Park, a randomly selected sample of 200 climbers are asked whether they have ever had a climbing accident and whether they're certified climbers. The results are shown below. Suppose you are searching for a climbing partner at Yosemite and you meet Rob, Andrew, and Sarah. Rob thinks of himself as a free spirit. He climbs without any certification. Andrew is hoping to continue his lifelong streak of never having a climbing accident. You don't know anything about Sarah. Okay, so let's take a look. We have a data table here. And what the data table tells us is that you're either certified or not certified. And so we have that information about everyone, and we also have the information as to whether they had an accident or have never had an accident. So if you look at the certified, for example, only 2 out of 140 have had an accident, so it's very, very rare. In not certified, it's 6 out of 60, so that's 10%. So much more likely to get into an accident if you're not certified. With that being said, let's answer the question. So the first one says, what's the probability that Rob had an accident? Well, we know that Rob thinks of himself as a free spirit. He does not have a certification. So Rob is one of the people in this group here. So I know that Rob is one of these 60 people that is not certified. So knowing that he's not certified, he's one of these 60 people. The question is, what's the probability he's had an accident? Well, it looks like out of the not certified people, 6 out of 60. And I think we said that's 10%. 6 out of 60 is 10%. So I think if I'm looking at someone who is not certified, I'm going to say there's probably a 10% chance they've had an accident because in the table, 6 out of 60 fit that criteria. Probability that Andrew is certified. So what do we know about Andrew? Let's get a different color. Andrew is hoping to continue his lifelong streak of never having a climbing accident. Good for you, Andrew. You go, Glen Coco. So never had an accident. So we know Andrew is one of these people here. Andrew is one of the 192 that has never had an accident. And the question is, what's the probability he's certified? So out of the 192 that are certified, out of this 192, we have, the question is, what's the probability he's certified? So he's never had an accident. 192, 54 are certified, or sorry, 138. My bad, I looked at the wrong number. 138. So out of the 192 never accident people, 138 are certified. So that means 138 over 192 is going to be our percent chance for this. So 138 divided by 192 give me 71.88 if I'm rounding to the hundredth, 71.88%. All right, probability that Sarah is certified. So do we know anything about Sarah? It says you don't know anything about Sarah. Let's underline that. So you don't know anything about Sarah. Well, I know her name, so that's not true. I don't know anything about Sarah. So for Sarah, it's a little trickier. I'm not looking at a specific row or column. I just know that Sarah's somewhere in the data. So Sarah is one of these 200 people. And the question is, what's the probability she's certified? Well, I know that 140 out of 200 are certified. So I'm going to go with 140 out of 200. And you might be able to do this in your head, reduce this in half, 70 over 100. So that's going to give you 70%, 70%. So 70% chance that Sarah is certified, assuming she's someone in this data table. All right, looks good. Question says, there was once a fantastic football player named Grom Shady. I'm going to guess that's Tom Brady. People always praise him for being so tough. They said when he played in harsh conditions like snow or frigid temperatures, he always won. I have heard that about Tom Brady. After analyzing data, however, statisticians determined that there was no association between Grom winning and Grom playing in harsh conditions. The frequency table below shows data for the games that Grom played. So it really doesn't matter if Grom Shady, I'm going to call him Tom Brady. It doesn't matter if Tom Brady is in normal conditions or harsh conditions, same chance of winning. So all of these boxes are empty here. What I'm actually going to do is look at Brady's overall win percentage. And this does look like Tom Brady because he's winning a lot more than he's losing. So overall, Brady is winning 152 out of 190 games. Good job, Tom Brady. And then he's losing 38 out of 190. So if I do those, if I find the percentages there, what's that going to look like? 152 over 190. So Brady is winning 80% of his games. Love that. Nice clean number. So 80% of the time, Brady's going to win. 20% time, they're going to lose. And the conditions don't matter. So that helps us a lot in answering this question. So what I can do is I can start by looking at the normal conditions. There's 150 games. And I know that 80% of the time, Brady won. 20% time was a loss. So out of the 150 games, 150, if I want to find 80% of that, I'm going to multiply it by 0.8, so it's 0.8. So that means 120. So 120 out of 150 he won. That leaves the leftover 30 as losses. And we have 80% as well. 80% of 40, you may as well do this in a calculator. You could probably do it in your head as well. But you could do 40 times 0.8. The way you could do this is 80% of 10 is 8, and you can multiply that by 4. So we should get 32. So 32 wins, and that leaves 8 losses since there were 40 games in harsh conditions. So what this data table is now telling us is it doesn't matter whether the conditions are normal or harsh. Brady has an 80% chance of winning the game, 20% chance of losing.